Hello, today I'm going to explain to you what's the difference between the PyTorch cat and the stack function. I really had a hard time understanding these two functions and what they really mean respectively. So let's get started. So first we'll have a 2x2 tensor 1, 2, 3, 4, and I will explain to you with these four situations cat along the 0 dimension. What it will do is that the cat will focus on the outer bracket. So we highlight this outer bracket, and to better understand this, we can put an arrow here like this, so it will look like a train connecting one another. Okay, so when we are doing the cat along the 0th dimension, it will be like a train connect to the other. So that will be like the first element of that row would be 1, 2, and then followed by 3, 4, and then because that is a train, so the 3, 4 will be followed by what is inside this train, right? That is 1, 2, and followed by 3, 4. So the result of concatenating these 2x2 tensors along its 0th dimension will be like 1, 2, 3, 4, 1, 2, 3, 4. Okay, let's try to follow the train metaphor for this cat function. It really helps you understand what that really means behind the scenes. Okay, when we are doing the cat function along this first dimension, that means that first we need to identify where the first dimension is. That is this bracket, right? Okay, so we highlight this bracket and try to make it like a train. Okay, so that will be like highlighted in orange highlighter, and also we highlight this bracket which represents the first dimension, and also remember we need to put an arrow like this so that it will look like a train connecting another. Also, this 2x2 matrix not only have one element in its first dimension, it also has another, so we need to use another colored highlighter to highlight this bracket and making it like a train. Also do the same for the second tensor like this. Okay, so remember what we did at the first example. We tried to connect the train one to another, right? So in this case, we do the same. This orange train would be connected to the second orange train. So the result would be like 1, 2, within the same bracket, 1, 2. And for the second one, the yellow will connect to the yellow. So 3, 4, followed by comma 3, 4. So the resulting tensor would be like 1, 2, 1, 2, 3, 4, 3, 4. That is a train connecting one another along the first dimension, you know. Just remember that it is important to identify the bracket in that dimension. Just like when we are in the 0th dimension, it will just require us to highlight one bracket because there's only one element in the 0th dimension, right, for a 2x2 tensor. However, for the same tensor, we can identify two elements in the first dimension, which is 1, 2, and 3, 4. So that is the key point to note, to keep in mind. Okay, so now we are going to use the same metaphor, which is the train metaphor, to explain what stack is doing behind the scene. Okay, let's do this. For the same 2x2 tensor, we try to use the stack, stacking two of these together along the 0th dimension. What's the difference between the cat and the stack is that the stack function will require us to add another bracket along the specified dimension. What I mean is that for this one, the 0th dimension, it will be like this bracket, right? Just like what we did in the cat 1. Okay, but now the stack, what really needs us to do is to add another bracket, just one layer outer. Okay, so we do this. We draw a train by enclosing this 0th dimension bracket. So we do something like this. And remember, we need to add the arrow here, and also we do the same. Add a new bracket along the specified dimension here, and then put an arrow at the end of it. So, and then we need to connect the train one to the another. So the resulting tensor would be like this train connecting another. Can you see the difference for the cat? Because this bracket is already the train, it's already part of the train, while in the stack function, the original bracket for the specified dimension is no longer the train that we are looking at. The train is one layer bigger than the original one, so we can just see this. We got this tensor as one intact component that couldn't be modified. So to do the same, we connect the train. Actually, we are concatenating the content inside the train, just like what we did here. So the resulting tensor from stacking these 2x2 2x2 tensor together would be something like this: 1, 2, 3, 4 bracket, followed by another 1, 2, 3, 4 bracket, and then a big outer bracket at the end. Okay, so for the last example, that will be more challenging, but the same reasoning is applicable to this. So for this example, we are trying to stacking these two tensors along the first dimension. First, for the stack function, we need to identify where's the first dimension. It would be like this, right? But also remember that for stack function, we need to add an outer bracket along with the identified dimension, that is, add a bracket in between the outer bracket and the inner bracket. That means in between here. So we create a train that encloses this element, and then we put a arrow sign here as the connector between the train. And also we do the same for the second tensor that is here, just between the outer layer and the inner layer here. And also don't forget to put the arrow at the end of the train. Okay, so because along the first dimension we have two elements, so what we need to do is to add an outer bracket along with the specified dimension, which is the first dimension, which is 3, 4 here. So you can see we have it enclosed by a yellow train here, and then with a connector, and then do the same for the second tensor. So the next step we need to do is to connect this string. Remember, for this one, because 1, 2, this array, this tensor is an intact component which cannot be modified. So this element will be concatenated by the second one without breaking this bracket, because the train is just here. Okay, so for this one, the resulting matrix, the resulting tensor would be like 1, 2, 1, 2, and then with this bracket, oh, you remember this bracket? This bracket It's just the orange bracket that we highlighted here. You know, the stack function requires us to add one additional bracket along the specified dimension, right? So we do the same for the second element along the first dimension, which is like bracket. Okay, we concatenate this, so we just move this part from here to here and put a comma here. So we have a 3 4 bracketed, comma 3 4 3 4. So that is the resulting element. That is the resulting tensor for using the stack function along its first dimension. So I hope this tutorial really helps you to understand what the difference between the cat and stack in the PyTorch. Keep it up.